Okay, so let's jump right in. We are about to pull back the curtain on a pretty incredible mystery that's happening inside your body at this very moment. It's a story about a secret defense program that could totally change the way you think about the fuel that runs your life. So here it is, the central puzzle. We've all heard that sugar is the body's go-to for quick energy, right? It's the high-octane fuel. So why, when you're just sitting down not doing much of anything, does your body choose to burn fat? It's a much slower, more complicated process. It seems kind of backward. And, the usual answers about energy storage just don't quite cut it.
All right, so here's our game plan. First, we're going to tackle that fuel paradox head-on. Then we'll uncover a hidden danger lurking within sugar itself. That'll lead us to this really fascinating new idea called the safe dissipation theory. From there, we'll check out the evidence, and finally, we'll connect all the dots to see what this all means for us living in the modern world. Okay, part 1. The body's fuel paradox. The big idea here is that your body's choice of fuel isn't just about getting the most energy, the most bang for your buck. No, there is a much deeper, much smarter game going on.
This right here really lays out the contradiction perfectly. On one side, you've got glucose, or sugar. Think of it as the jet fuel of your metabolism. It's super fast, super efficient. But then you've got fat. And even though it takes longer to get going, it's the preferred fuel when you're just chilling out. So why would your body prefer the slow-burning log when it has the fast-burning gasoline right there? That is the question we need to answer.
And that question brings us to a huge plot twist. See, the answer isn't really about the energy in the fuel. It's about the potential damage that one of these fuels can cause over a lifetime. And this is where the story gets really, really interesting. The bad guy in our story has a name. It's called glycation. To put it simply, this is what happens when rogue sugar molecules floating around in your blood just randomly latch onto your vital proteins and fats. This isn't a controlled biological reaction. It's just chaotic chemistry. It basically gums up the machinery of your body. And the worst part? The damage is permanent. I love this analogy. Think of glycation as a kind of slow-motion rust that's happening inside your body, on a molecular level. It takes these beautiful, flexible, functional proteins and just makes them stiff, brittle, and useless. It is, quite literally, a fundamental process of aging. So which parts of you are most vulnerable to this rusting? Well, it's the proteins that are supposed to last you your entire life. We're talking about the collagen that keeps your skin firm and your joints moving smoothly, the elastin that keeps your arteries flexible, the crystal-clear proteins in the lens of your eye, even the microscopic scaffolding that holds your brain together. These are the very structures that glycation slowly but surely degrades over time. So, if your body is under this constant threat of molecular rust, how does it fight back? Well, this brings us to the hero of our story, a really elegant new theory called the Safe Dissipation Hypothesis. This quote from the researchers really gets to the heart of the whole thing. What they're proposing is that our bodies prefer to burn fat not for energy, but as a defense mechanism, an incredibly sophisticated program that evolved to protect us from the slow, steady damage of glycation. And that's the key takeaway, right there. Your metabolism's main job, its default setting, isn't just get energy, it's protect the machine. The #1 priority, according to this idea, is long-term molecular preservation. It's about playing the long game for survival, not just getting a short-term energy boost. This diagram shows us exactly how it works. Let's look at the top section, the adaptive state. This is your body in its happy, healthy mode. We're burning fat, and a special gatekeeper molecule is actually blocking glucose from being used unnecessarily. Meanwhile, a cleanup crew is getting rid of any harmful junk. And the result? Our critical proteins are preserved, which helps us live longer, healthier lives.
Now compare that to the bottom half, the pathological state. This is what happens when we just overwhelm the system with too much sugar. Our defenses can't keep up, glycation runs wild, and all these toxic byproducts start to build up. And what does that lead to? Well, at least directly to molecular damage, which looks a lot like accelerated aging and chronic disease. The difference between the two states is just night and day.
Okay, so it's a really compelling theory, but is there any evidence for it? Oh yeah. Our bodies, and the bodies of other animals, are packed with tools that are specifically designed for this fight. Let's take a look at the toolkit.
You could think of it like a 4-layered defense system. First, you've got the gatekeeper, PDK4, whose whole job is to say, nope, no unnecessary sugar burning right now. Then there's the cleanup crew, GLO1, which swoops in and neutralizes the toxic waste. Your liver acts as a massive filter, soaking up sugar after you eat. And finally, when you haven't eaten for a while, your body produces ketones, a super clean, non-damaging fuel source that your brain absolutely loves.
And what's really amazing is when you look across the animal kingdom, you see different animals have all figured out unique ways to solve this same glycation problem. Cats, for example, evolved to use almost no sugar, which is why modern high-carb pet foods can be so bad for them. Whales do it with a super slow metabolism. Naked mole rats have these incredible protein repair systems. And us, our evolutionary superpower is metabolic flexibility, the ability to dynamically switch between fuels to protect ourselves.
So this brings us to the final and maybe the most critical piece of the puzzle. What happens when you take this ancient, finely tuned protective system and drop it into the middle of our crazy modern world?
I mean, think about it. For nearly all of human history, our bodies were built for a world of scarcity. We evolved to thrive in a cycle of feast, where we'd get food and store energy, followed by much longer periods of famine, where our bodies would flip that switch into our fat-burning, protein-preserving, safe mode.
But today, for so many of us, the famine never comes. It's just feast, followed by another feast, and then a snack. We live in a state of constant, non-stop food availability that our ancient metabolism was just never designed for. And as the researchers point out in this quote, this constant barrage of sugar just completely short-circuits that ancestral balance. It basically gets our bodies stuck in high glucose mode, never giving them a chance to switch back to that protective, fat-burning state. Our anti-glycation defenses just get totally overwhelmed. So what's the big takeaway here? This whole idea really reframes how we should think about health. A lot of chronic diseases, you can see them as a failure of this safe dissipation system. Those markers of aging might be less about how many birthdays you've had and more about this metabolic mismatch. And the best part? It suggests that through our lifestyle choices, we can actually reactivate these ancient protective programs.
So I'll just leave you with this final thought. We now know that our bodies have this incredible built-in preservation program, something that evolved over millions of years to protect us from the inside out. The real challenge for all of us then is to figure out how we can live our modern lives in a way that actually respects and supports that ancient protective wisdom.